My name is Ken Duda. I'm one of the original founders of Arista Networks. I'm also the company's CTO, and I run our software team. And I'm really excited to talk to you about what we're doing here with the management plane, because I think the management plane of the network has been a very challenging place in the past. Oh, I would like to say I love questions, so please interrupt, jump in with anything on your mind. I really appreciate that. So I'm going to take a step back here and take a look at the network, kind of a broad 40-year kind of industry view. And I think we all understand the network as a fabric made of physical devices, human operators with three planes: a data plane, control plane, and management plane. And the data plane, I think most people would agree, the industry's done a pretty darn good job of giving customers the primitives they need, the building blocks they need to assemble complex, feature-rich, high-performance, multi-service, multiple administrative domains of control, well-standardized interoperating networks. This is a pretty small set of standards. Darwin has been pretty active in this space. It's gotten rid of stuff like Sonnet, FDDI, ATM, frame relay, right? It's all died a horrible death, and what's taken over, of course, is Ethernet, IP forwarding, MAC bridging, MPLS, label operations, some tunneling technologies, GRE, VXLAN, very important, some security technologies, IPsec, MACsec. That's pretty much it. And the data path has become a really a very simple and scalable place that I think the industry as a whole has given our customers the tools they need. If you look at the control plane, I'm not sure everybody would agree with me here, but I actually argue the same kind of success has been had here by the industry. The control plane is well standardized, it's multi-vendor, it federates well across administrative domains, across organizational boundaries, scales very well. I'm talking here about protocols like the link layer, BFD, and LACP, bridging control protocols, routing, BGP, all the IGPs, then traffic engineering, LDP, RSCPTE, and then overlay technologies like L3 VPN, VPLS, and EVPN. It's a larger set of technologies than at the data plane, but I think, like the data plane, the industry's done a good job of giving our customers what they need to build advanced scalable networks. Now let's move on to the management plane, shall we? Like, what happened? Where are the building blocks? How is a customer supposed to construct a management plane out of what vendors provide? It doesn't exist. What network vendors actually provide isn't a management plane at all. It's access methods. The CLI gives you access into one device. SNMP lets you pull one device, and even OpenConfig is really just an access method for streaming configuration updates and telemetry information in and out of a single device. But how do you create the plane? How do you create this sort of the network-wide view, the autonomous sort of automation of the network functions at the management level? The way the control plane autonomously figures out paths through your network. What's up with the management plane? It's just not there. The most sophisticated operators invest tens of millions of dollars building their own management planes. The cloud operators do that. The world's largest carriers do that. But for most enterprise customers, this is just out of reach, and they fundamentally do without. We might buy some third-party tools that do some basic things, but they don't wind up with a management plane anything like what the big network operators use. So I think unlike the control plane and the data plane, the industry has essentially abandoned our customers in the management plane. And Arista aims to change that. We believe that it's time to launch an industry-wide initiative to build a cognitive management plane, something that's well standardized, multi-vendor, that federates across geographies, across administrative boundaries, truly scales to worldwide scale networks, enabling our customers to build a management plane that does the kinds of things that the most advanced operators have built themselves around the automated provisioning of equipment. When equipment fails, replacing it with new equipment and having it just work on its own. Network-wide configuration updates, network-wide image management when you need to roll out new software, compliance monitoring, alerts, making sure your network is behaving the way it's supposed to be behaving, streaming all the telemetry information out of the network and analyzing that, using that as a source for machine learning that can do things like adaptive alerts, make capacity forecasts, predict when you're going to hit bottlenecks, do root cause analysis of outages, and then analyze your historical data for troubleshooting purposes, for forensics in the case of break-ins or attacks, and then for profiling devices and applications so that you can understand the behavior of the devices, the applications you're running, the services you're providing, how the actual dynamic behavior is working out. All of these features could be built on a proper management plane if the vendors would provide the right building blocks. So what we believe the building blocks fundamentally should look like is to take your network and segment it into zones where each zone consists maybe of devices under common administrative control, maybe a common type of device, maybe all from the same manufacturer, maybe all providing a similar role or function in the network, some segmenting your network, just as, of course, all large operators do, BGP areas or whatever. And then for each segment, stream all of the state of those devices out of the devices into a cluster. The management plane, so the control plane and the data plane run on box. I think one of the reasons our industry has been so slow to provide a proper management plane is that management planes belong off box. The management plane fundamentally should be implemented as a bank of servers with a lot of storage and a lot of compute, monitoring and understanding the behavior of the network. So you need to stream all of the state out of the physical devices into the cluster, into some kind of a network-wide database where you can keep the current state view, but also all the historical information, because this state is the foundation of an advanced management plane. On top of that state database, you should run a stream computation engine, and this is what CloudVision actually does today. Stream computation processes state updates as they come in and transforms, aggregates, summarizes, analyzes, converts from a device-specific idiosyncratic representation into standardized representations. And then on top of that, you can then run applications that give the user views of that sort of derived data, the output from your stream computation engine. And then the next step, of course, is to recognize that in order to scale, just like two routers can peer and exchange reachability and traffic engineering information across those two routers, management clusters need to do the same thing. One management cluster should be able to peer with another management cluster, maybe from a different vendor, maybe for a different type of device, maybe being operated by a different operator. Devices managed by different operators peer via BGP all the time. And then on each side, configure export and import policy, just like the way you do with BGP today. And then stream management state from one cluster to the other. For example, using standardized protocols, like OpenConfig looks like a very suitable protocol for this kind of state streaming. And this gives you support for scale. You can now scale your management plane across multiple geographies, administrative domains. It gives you support for redundancy because you can now have multiple management clusters for critical infrastructure, and multi-vendor support, because it makes the most sense to me, at least, for a given cluster to bind tightly to devices from that manufacturer, because you can understand the idiosyncratic details of those devices, but then transform that into well-standardized models to federate with other clusters that might be responsible for devices from another manufacturer.
So when you're talking another manufacturer, I'm going to make a leap here, and you're talking about Mojo maybe, and considering, are you guys just going to get them to start running your native OS? I'm kind of curious about that.
Sure. Mojo's been in business for, I think, 15 years and has built quite a lot of very advanced software that's obviously built completely independently of Arista and EOS. And we expect that the Mojo software will continue to exist in a form very much like its current form for quite a long time. Okay. They've done an extremely good job, and they've built actually an architecture which Murthy will talk about later in the session, which is very similar to the CloudVision architecture. And for me personally, that was a major appeal of the company. The fact that they had constructed a management cluster essentially exactly the way I would have done it. You know what I mean? So we absolutely are peering with the Mojo management system in this manner, but I certainly don't intend to limit this architecture to simply Arista and companies that we acquire.
Okay.
And we very much look forward to working with partners and others in the industry to extend the cognitive management plane to really meet our customers' needs. I mean, it's sort of like if you're doing routing and you invent a routing protocol that only your own devices speak. you might get a certain distance with that. But to really have the kind of impact on the industry that you want to have, to solve customer problems at scale, that doesn't work. Customer networks are going to be multi-vendor for the foreseeable future. And I actually think that the customers are better off that way, and the industry is better off that way. And the sooner the industry can kind of figure this out and cooperate at the management plane level, the better off customers will be, and the better off the individual industry participants will be. This sort of effort that some go into to try to lock their customers into a single vendor solution is a very silly approach. It's not good for the customer, which means in the long run, it's not even good for the company that's pushing it.
So how do you see the integration between CloudVision and Mojo product working? Do you think that there's going to be some changes to the fundamental architecture of how that's working? Are you going
But that's the beautiful thing, is we don't have to change the fundamental architecture. We've both implemented this architecture already. So we both have the state streaming out of our devices and streaming into a big data backend where we have not just the current state of the network, but the full historical record of what the state has been, data that serves as a foundation for machine learning and advanced analytics and all those great functions. And what we're doing to integrate is what's shown on this figure. Exchanging state between the two management environments such that the customer gets a seamless experience. For example, if one vendor has a really good network troubleshooting application, then what we can do is stream flow data, stream packet traces, stream the sort of raw information from one cluster into the cluster where the application is running that does the really great troubleshooting, say of association issues with DHCP and 802.1x and like all the sort of authentication and association issues. We can stream that state across, and then the diagnostic system has more information to draw on. It can show the data that's relevant to the problem being troubleshot, even when that data came from a different management platform, if it's streamed in a standardized way.
So do you think that'll be included in CloudVision soon, or do you see that as years off? Like, what is the time frame in that? To be able to see that?
I'm not going to commit to a time frame here, but we're actively working on this, and I expect we'll have early versions soon.
You talk about creating an industry-wide initiative to facilitate a lot of this. How difficult do you see that being, and what, in your opinion, would the time frame on something like that be to try to get other vendors in this industry to take that up and incorporate that into their product lines?
It's going to be challenging for sure. And I think that right now the main vendor that is kind of most important to sort of make this happen is a little busy trying to kill us and not rather than partner with us. Uh-huh. So it's not going to be easy. But I think that the way I see this evolving is that we're going to need to prove this out, show the value, and get customers to the point where customers are saying, come on guys, we've got to have this. You got to do it, or else we're going to have to go with a different solution. And at that point, I think we'll get some cooperation. So I don't know when that tipping point comes. I don't know when there's enough customers who say, this is a must-have for us, that we can really push this forward. I don't know if it's 2 years or 5 years or 10 years. But I think it's a goal worth shooting for, because I think this has a potential to make networks fundamentally better to operate. I haven't seen anything like it in my career around how to really fundamentally improve the sort of manageability of networks. Any other questions? Great. So I'd like to close here with a couple of just examples of what we've built here. So what we see on this screenshot is CloudVision. CloudVision has a topology viewer that shows you a kind of a logical graph of your network, and we've extended that to support campus. And so this is the operator's Houston campus with an edge router, a couple of spine switches, and then with connections to each floor of their building. Each floor has an access switch, and then which connects to various devices, including wired computers and IP phones, as well as access points. And so the device that's been selected here is an access point that the operator is wondering maybe there's some kind of an issue with. And one of the really neat features of CloudVision's topology viewer are the layers, the ability to overlay other operational data on top of the topology view. So in this case, we're going to go over here to the left and click on bandwidth utilization to see if there's maybe a traffic load problem that's leading to dodgy application performance. So you click on the bandwidth utilization, and then each of the links gets an overlay indicating its sort of percentage utilization. And what we can see is there's one access point here which is pinned. And so then we can look at that access point's details, and then from there go over to the mobility wireless manager side of things and see some of the neat network analysis features that the Mojo's built over there, including seeing that the network usage has shown a spike recently, and that the quality of experience monitor has shown that there's a couple of application quality of experience issues that it's concerned about that may very well be linked to the increase in traffic.
Speak to what is used to baseline that last one, the client experience. I mean, what metrics are being used? Can you talk to that?
Ruthie, are you planning to talk about the quality of experience in your talk?
Sure, yeah.
Okay, so we can talk about that more in Ruthie's talk, but what I would say briefly is that the way the application quality of experience work was done was by picking specific applications, gathering real network data about how the network was performing as those applications were being used, collecting user perception information about what users thought about the quality of experience, and then training a machine learning model about which attributes of the network traffic best predict the user's perceived response. And then once that model has been trained, you can then apply that model efficiently against live network data as it comes in, and then generate these quality of experience events. So it's application specific. It requires training for different applications, but it's very powerful.
Okay.
Yes?
Can you flip back one, please?
Yeah, sure. Maybe. There it is.
Okay, so just a couple of basic things to help us understand the transition and what's happening, what's not. So this is going to remain a Mojo access point, or this is now a Arista access point?
I'm not sure what the difference would be. Sounds like a branding difference. I'll let the branding people decide. And we acquired Mojo, right? So
I'm just wondering, am I ordering Mojo or am I ordering Arista? I'm just...
John?
Yeah, so we're going to keep the same access point model with the disaggregated model that Mojo had. At some point, they'll show up with the Arista logo instead of the Mojo logo, but it will be the same thing, and we'll carry forward with the same approach to access points that Mojo's taken in the past.
And under the hood, at least for the short future, it's still Mojo OS under the hood.
Correct. Absolutely.
So people with current Mojo APs will be able to continue once you...
Absolutely.
Oh, absolutely.
And what we're seeing, I'm sorry to interrupt, and what we're seeing right now, but I'm going to.
Please do.
What we're seeing right now is not beta, this is real. So if I wanted to buy Arista, full stack, whatever, we're looking at it, and it's available now.
I don't think I made any representations like that.
Okay.
So this is...
Again, just looking for clarity.
This is our campus extensions to CVP, to CloudVision, are not yet shipping. I'm not sure if we have a committed schedule for that.
Yeah, so it's, I think we're 4 weeks, Rick, into this adventure. Yep. So this is the progress as of 4 weeks.
Okay.
You can expect this coming and shipping product, and more technical integration over subsequent releases with Mojo and CloudVision.
Very good.
The other thing I think, just to contextualize that comment, is we're seeing work in progress. Excellent time to give feedback. So we can influence this roadmap greatly if you guys have any comments.
And the only reason I'm asking as specific as I am is to look at this. It doesn't really ground us in where you are in that transition. That just looking for clarity, that's all.
Yeah, I think I would characterize where we are as early.
Yep.
Right.
Good enough.
Yeah.
So to talk about CloudVision for just a little bit, say for an existing Arista customer, how is that currently licensed? What's the model there as far as the way that works?
Jeff, do you want to jump in on that?
So the question with regard to CloudVision is a software subscription service.
Okay.
And we offer it as a virtual appliance. There's also a physical appliance. It's deployed on-prem, and it's basically applicable to anywhere, at least to date, anywhere that our EOS software exists. So today we have customers using our EOS software in the data center, in routing use cases, in the public cloud. There's virtual EOS, there's containerized EOS, there's EOS that runs on third-party white boxes. In the switching and routing world, CloudVision is applicable to all those use cases today. What Ken's kind of showing here is expanding that to include, you know, a common management plane, a common UI for integrating wired and wireless as well.
Okay, thank you.
We wanted to make, yes, please.
Question while we're on the hardware. In previous Mojo Tech Field Day events, they talked about going with Whitebox APs, kind of a thing they were pushing. Is that going to be continued?
Yeah, so we're continuing with what we would call the disaggregated model for APs. So we're working with third parties that are building APs using industry standard chipsets. While we're designing our own hardware on the LAN switching side, this does conceptually fit our model. We're doing containerized EOS as well as VEOS, which we're putting on standard servers for some routing applications. So Mojo will continue with the third-party APs. They'll be Arista certified and branded for a better name, but completely working with the ODM stack.